Hello and welcome. Today we are talking about basic statistics and measures of center. Let's go ahead and start things off with a little bit of vocabulary. More specifically, quantitative and qualitative data. Quantitative data refers to numerical values and answers questions of how much or how many of something we have. Qualitative or categorical data refers to non-numerical categories. This is useful for tracking things like preferences or any type of data that does not involve any actual numbers. Next, we're going to go through some common types of charts and graphs. Here we see a pie chart and a bar graph. Both of these are giving examples of categorical or qualitative data, with each wedge of the pie chart representing courses taken by different students, and each bar of the bar graph representing different types of movies. Here we see a dot plot and a histogram, both of which are showing quantitative data, with the dot plot showing the number of kilometers run by members of the running club, and the histogram breaking down a population by range of age. Here we have a scatter plot and a box plot, again showing examples of ways to display quantitative data. And finally, we have a frequency table and a bell curve or a distribution curve. In both of these figures, the frequency represents how many times a specific item showed up in your data. So here we can see there were 12 cars, 2 buses, 3 bikes. And in our bell curve, we can see that the heights with the highest frequencies were in this region here. So the most common height was somewhere around 5'5". When measuring a set of quantitative data, we're generally going to want to look at the numbers in numerical order, either from least to greatest or greatest to least. Once our data has been organized, we will generally be asked for a 5-number summary. The 5-number summary refers to the minimum value, the maximum value, the median value, the first quartile, and the third quartile. So in other words, we want the lowest number, the highest number, the middle number, and then the numbers that are halfway between the highest and middle, and then middle and highest. So using the integers from 1 to 11 as an example, we'll start by identifying our minimum and maximum. To find the median, I'm going to split my set in half. So I have 11 terms in total. Divide that number in half to get 5.5. This tells me that I need 5 terms on either side of my median. If I then mark off 5 terms from the left and 5 terms on the right, I notice that the 6 is left over in the middle. Therefore, the 6 is my median. Finding the quartiles, we'll use the same process, but instead of using the entire set of data, we'll only look at each half individually. So to find quartile 1, we'll look for the median of the lower half of data. Because our lower half has 5 terms, we'll count 2 from each side, which will meet in the middle at 3. To find Q3, we'll find the median of the upper half of our data. Once again, our upper half has 5 terms, So we'll count 2 from the left, 2 from the right, and where they meet in the middle is Q3. So the 5-number summary of our data is the minimum at 1, Q1 at 3, the median at 6, Q3 at 9, and the maximum at 11. If we want to use Desmos to help us out, we can enter lists by using the flat brackets. We can then find the 5-number summary by using the correct commands in our Desmos lines. So notice I had my list saved as A. So then my commands are min, median, max, and then quartile. With quartile, I do have to specify which one I want. So here I typed quartile A, 1 to tell Desmos that I wanted to use the numbers from list A, and I'm looking for the first quartile. To find Q3, I do the same thing, but I change the 1 to a 3. To display a 5-number summary visually, we usually do that using a box plot. So if we notice on the box plot, the minimum, median, maximum are here, and then the edges of the box represent the 2 quartiles. Desmos can draw box plots as well using just box plot as the command. Notice it displays just like this. And once again, we can see minimum, quarter 1, median, quartile 3, and maximum. When we talk about measures of center, we are usually looking for numbers that help us summarize a set of data. The median is one such measure of center because it helps us find the middle of a data set, which helps us know that half of the values are above the median and half are below. 2 other common measures of center are mode and mean. The mode tells us the value that reoccurs the most often in a given set. And the mean or the average helps us find a balance point for a set of data, which we find by adding up all of the terms in the set and then dividing by the number of terms that we had. So if I wanted the mean of the numbers from 1 to 11, I would first add all of those numbers up, which means I either need to just type them out one by one or use the total command. Then I need to divide that number by the number of terms that we had. So the average of our set is 6 because the total was 66 and there were 11 terms. So when I ask Desmos for a mean, that's the process that it's using to come up with that number. For our last bit of vocabulary, we're going to go ahead and talk about the shape of a set of data. If we have a normal or symmetric data set, the mean, median, and mode will all have the same value. When this happens, we get a nice symmetric little curve like this, where the left side and the right side match. If our mean, median, and mode are not the same, then we end up with skewed data. The skew is based on where the mean is in relation to the median. So if the mean is to the right of the median, then we say it's a right skewed curve. And if the mean is to the left of the median, we say we have a left skewed curve. If you have trouble remembering, think of this almost like going down a slide. So if you've ever seen a slide on a playground, you have to climb up the ladder and then slide down. Over here, again, I'm going to climb up the ladder and then slide down. And whichever way my slide is pointing, that's the direction of the skew. And that's all I have for this one. I'll see you guys next time.